Okay, so we have finally entered into RAG, Retrieval Augmented Generation. So let's go ahead and first understand what exactly is this RAG. Then we are going to cover why do we need RAG and how our company is using it, and how can you build a prompt for RAG. And finally, we are going to take a look at the summary. So these are the things that we're going to cover in this particular lesson. But in the later courses, in the later lessons, we are going to understand what is a vector database. We will understand different types of parsing techniques, and we're going to use Azure Document Intelligence for parsing a document. Then we are going to build a proper RAG backend in VS Code as a proper Python repository. And finally, we'll cover some of the common problems that we'll face when we are building a RAG. But to do all of this, first we need to understand what exactly is RAG. So RAG stands for Retrieval Augmented Generation, and the definition is in the name itself, Retrieval Augmented Generation. Three parts. There are three different steps when we are building a RAG. First step is retrieval, second is augmentation. Third is the generation part, which LLM is going to do. But let's first understand what is retrieval and what is augmentation. If I go back to my whiteboard, let's take the input output from here. I have this as my input and this is my output. But to get this output, this input is not sufficient directly. Let's assume that my input is uh, how many offices or how many factories does Apple have in India? This is my question. And I'm not able to get the answer because my LLM model does not know the actual answer for this one. Because as we discussed in the last lesson, it has a limitation for the training data. So if the training data was only up to June 22nd, 2024, then it cannot answer anything which has happened after that particular date. To be honest, it's a bit before that particular date because they'll take at least couple of months to prepare the data properly. Okay, nonetheless, the LLM model is not in a position to answer this question. Now, similarly, if I go into L&T website, Larsen and Turbo, this one. Okay, so here there are many different things that L&T does. But for example, I need to know what are the different programs that they have for data science. What job roles do they have? Do they even have a data science wing in their company? If I want to know about all those things, I need to do all of my research. Let's say if it is for uh, knowing about any particular person. For example, I want to understand who is the CTO of your company, or who is the person I can reach out to related to data science stuff in this company. There's no way for me to know that directly here. I need to do my research. Now, the easiest solution is to have a chatbot, and I can ask the chatbot, and the chatbot can respond to me. This is one of the most common use case where you'll see a RAG. So, chatbot is one such use case where you'll need a RAG in the backend. So, what this chatbot is going to do is, along with my input, it will take my input. First of all, sorry, it will take my input. Then it is going to get some relevant content, and it will be able to write this answer. There will be a few more components in between. For example, the answer is written by an LLM. So I'll put it like this. And For this LLM, we are taking the input and the relevant content, both of them, and then we are going to send it at once. And we'll tell the LLM, okay, this is what the user has asked, and this is the relevant content that we have with respect to that question. Try to answer that user question from this content. Feel free to use the information present in this content to answer that input, to answer that question. That is how we are going to tell our LLM. We'll frame the prompt in that way. Now this is my enhanced prompt, which I'll be sending to my LLM model, which will get me the output. So how am I getting this enhanced prompt? Let me pull it down. Let's imagine I have a database. So this is my database about the company. Now I've got this retriever, which is a function. So this retriever function is responsible for creating this enhanced prompt. So whenever the user asks any question, we will send it to the retriever function. The retriever function is going to communicate back and forth with, I can do it like this, right? Yeah. So it's going to communicate back and forth with my database about the company, and then it will get me the relevant content. Actually, you know what? I'll write a query here. Yeah, I'll write a query. This will give me the relevant content. That relevant content along with the prompt is going to be considered as the enhanced prompt. This enhanced prompt is what we will send to LLM model and we'll get the out. Let's take a simple example. My input in this case is, who is your CEO? Now my retriever function will go to the database. Who is the CEO? This guy. This is the content that I've retrieved. This whole thing is my enhanced prompt. So the retriever function has created this enhanced prompt. Now we will send it to the LLM model. The output is going to be like this. Very simple, very straightforward, very simple logic, to be honest. The only thing that you have to understand is the retriever component is responsible only for getting the relevant content, nothing more than that. The LLM will use only these two things, whatever you're asking and whatever you're attaching as the relevant content. Only these two will be used for generation of the answer. Now, this is retrieval, this is generation. Where exactly do we have augmentation? So I think you might have guessed already. This is where we have augmentation, the middle part. What is augmentation? Augmentation is nothing but if you are enhancing something, if you're changing something from one way to the other, if you're improving it, then you call it as augmentation. For those who know how neural networks are trained, how convolution neural networks are trained in deep learning, image augmentation is one of the most important component, where you'll take an image, you'll skew it, you will rotate it, you'll morph it, you'll do all sort of things to generate more and more training data. It's somewhat similar to that. We will take the original prompt and we are going to create an augmented version of it called as enhanced prompt, where you are simply attaching your relevant content and you will be passing it to the next step. This is how a RAG works. Very, very simple. Okay. There's nothing confusing about it. But the use cases are many. There are so many different ways in which you can build this RAG. There are so many different situations in which you can build a RAG. So let's try to understand all of them one by one. Why do we need a RAG? In what situations do we need a RAG? So first one is when you don't have up-to-date knowledge. So let's take the web search as an example. If I go to ChatGPT, I'll try to ask it the same question. Who is the current CEO of L&T? If you observed, it did a web search. I don't know if you guys were able to see that or not. Let's try to get it for different thing. Who is the CEO? Or let's ask another question. See, it has done a web search. So when it doesn't have enough information, it is doing a web search. So that also acts as a retriever function. So retriever function doesn't necessarily have to get something from a database itself. It can be from any source. The only function that it has to do, the only job it has to do is retrieve relevant content. So in this case, it went to web search and then it retrieved the web search results as the relevant content. But let's say if you have a chatbot for L&T website, they will have some sort of a database from which you can retrieve the relevant content. So when you want up-to-date knowledge, you have to implement RAG and increased accuracy. Uh, sorry, increased accuracy. So let's say you have built a chatbot for L&T itself. I'm pretty sure ChatGPT or any LLM model, the training data will definitely include a few things related to L&T, but that doesn't mean that it will include everything. And also, whatever output that you're going to get, it might not be accurate. Let's try it actually. Mumbai, Maharashtra. Doing any web search, using your ground knowledge was in where is L&T office in Mumbai, Maharashtra, and do that without doing any web search. You see that Powai, Mumbai, Maharashtra. But if you see the address here, this is in Ballad, totally different area. So even though the LLM model is trained on this data, the response that you're going to get is going to be inaccurate. This is hallucination. So to reduce these kind of hallucination, we have to implement RAG. This is the second situation. The third situation is use case versatility. So for example, you're working on a use case where the LLM has absolutely no idea about your data. For example, uh, if you have all of your data in a SQL database, or if you are storing all of your data in a very long PDF file, or let's say you have a very huge syllabus book that you have created, like a PDF. In those situations, you will have to implement a RAG because the LLM has absolutely no idea about that data. And finally, context specific responses. So this is what we are going to cover a lot more in detail in this entire course. And some of the most interesting use cases here you will find is database related chatbot or and NLP to SQL chatbots. These are two of the most very extremely common use cases that you'll find nowadays. So database doesn't mean just structured data. It can be unstructured. It can be vectorized databases as well, which we are going to explore in the very next session. So how do companies use RAG? First of all, company chatbots. So there are many different companies. If you go to their website, you'll have a chatbot just like this one, where you can ask questions and it will give you the answer. I'm pretty sure this Notion page is also using a RAG in the backend. NLP to SQL query assistants. So you have a huge database, many number of tables, and all of your data is sitting inside of it. Now, you don't want to write SQL queries, you just want to ask the question naturally, and we can let the retriever function write the query for you. It will fetch the relevant content, it will write the relevant query, it will get the output. That is going to become your relevant content. Your input plus relevant content will be sent to the LLM model as usual. But the retriever component is now writing SQL queries. It is not fetching anything from the file. It is not fetching anything from the web. It is writing SQL queries to fetch content from database. Similarly, for Confluence and SharePoint chatbots also, let's say if you are trying to find any particular file, or if you want to find out some information which is sitting in a file somewhere, we don't even know what file it is, where that file is, but all that information is present in your vector database. In those situations, you can build a proper chatbot. You can attach a vector database to your LLM model. Now, whenever you ask any question, it will answer you. And if you have built that vector database properly with some metadata like file name, file location, etc., you can get the answer. You can also get the file name, file location. We'll try to cover more of this in the later lessons of the course. Industry specific knowledge retrieval. So let's say if you take any specific industry like pharma industry or oil and refinery industry or any of these specific manufacturing kind of industries, in those areas, LLM model might not be performing the best because they are general purpose models, right? So if you take GPT model, they are general purpose model. They are not built specifically for pharmaceutical companies. You can fine tune it, of course, but it's going to come at a cost, and then you'll have to deploy it on an endpoint. You have to pay for the endpoint. It's such a hassle. So in those situations also, what we do is we implement a RAG in the backend where depending upon your question, you'll fetch all the relevant content and then you'll pass it. One simple example is if you take pharmaceutical companies or any medicine related companies. If the user is asking question about any particular disease, what happened? Okay. So if the user is asking question about a particular disease, then you'll go to your database, you'll fetch all the relevant content that you have about that particular disease, and you'll pass that along with the question to the LLM model. So these are the four different common areas in which we can implement RAG. Now, the ideal prompt structure. This is very, very important. So let's try to understand this in a whiteboard. So this enhanced prompt should be written in a proper structure. Many people ignore this when they are building a RAG. The very first section should be goal. What exactly are you trying to achieve? So in my case, we want to get the name of the CEO, right? That's the goal. Okay. Now, second, return format. What is this return format? In the very first, or sorry, in the second lesson, sorry, in the third lesson, we understood what is structured output, right? So similarly, in the return format, you will check or you will inform the LLM if you want a lengthy, long response, or if you want a short, quick one line response, or if you want, uh, how do you call that? JSON format response. You'll inform your LLM about your output format here. Okay, so this is your return format. Finally, warnings. Many people will ignore warnings, but they are very, very important. Warnings are essentially what not to do. If I have to give you a few examples, don't use emojis. Because if you're building a professional chatbot, then it will look very bad if you have emojis inside of it. If you see these kind of emojis, they'll totally ruin the overall tone and the user experience will be slightly off. So we don't want we don't want any emojis. Similarly, don't give headings, subheadings, etc. from the user. Okay. So these are some very, very simple and basic instructions, which of course you can implement. But if you are not implementing them, there's not much of a harm, I would say, because let's say if you are building a simple chatbot, if it has headings, it's fine, right? There's nothing wrong in having a heading and subheading, but it would be nice if you can get a simple paragraph answers. But there's not a huge loss if you don't write these warnings. But there is one warning that you definitely have to stress a lot, which is do not let the user know about the relevant content. This part is extremely important because you need to keep in mind that your user did not provide you the relevant content. He just asked, who is your CEO? But let's say if this paragraph, whatever relevant content I'm attaching here, if it doesn't have the necessary information, your LLM model will write a response saying that, I'm sorry, I was not able to find any information about CEO in your relevant content, in your attached paragraph. But the user is going to get confused because they didn't attach any paragraph, they didn't pass any relevant content, none of that. They just asked that question. So we need to write this part very properly, saying do not let the user know about the relevant content. If any info is not found, simply say not found. Actually, this is a bad way of writing a prompt. Actually, if you say simply say not found, it will always respond with not found, not found, not found, those two words. Instead, you should say inform the user you don't know. So these two are very, very important parts. Along with that, there's one more third part which usually we add, which is uh, if info is not found, ask the user to rewrite or ask again. So these three are extremely important warnings that you have to pass when you are working with a RAG backend. Okay, so this is about warnings, and we have one more thing, which is context dump. which is the actual relevant data, which is this one. Yeah. So this is how we can write the actual enhanced prompt. So this is how the overall structure has to be. The content that you're fetching from your database or whatever your retriever function is fetching, it should be at the very bottom, because whenever you're writing prompts, the important attention will be given to those things that are at the very top. And that is why we always put the question at the extreme top, and then the instructions, because it has to obey those instructions no matter what. Then finally we will have the relevant content, because sometimes you might have you might have the information present in the relevant content, sometimes you might not, but it always has to obey the instructions. That is why instructions will be at the top and the relevant content will be at the bottom. And the output format, of course, it has to follow it no matter what. That is why it will be at the topmost. And even above that, you will have the actual original question. So the attention mechanism works by focusing more on the starting parts and focusing less on the ending parts. And that is why we always put the not the unnecessary, but the least relevant things at the very bottom. So this is how we can write the enhanced prompt. These are the four different uh, sections in which you can divide your prompt into whenever we are working with RAG. So this was all about RAG, how we can, what exactly it is and why do we need it, how, in what situations do we use a RAG. Now let's go ahead and start understanding how can we build a RAG. So we'll start by understanding what is a vector database, and then we'll build a proper vector database. See you in the next lesson. Thank you.